Factoring by the greatest common factor is the first factoring method you always want to look for whenever you're considering factoring. That is because a lot of times you can factor out the GCF first and then be left with something else that can also be factored in another way. It also sometimes makes the problem a little smaller and more easy to recognize. So in this problem, I have two terms and I have x's and y's in both. So I want to kind of just go one at a time and just focus on the numbers. I know 9 and 15 are both divisible by 3. So I know that's the first part of my GCF. And when you're looking at variables with exponents, you usually are always going to choose the smallest one. So out of x cubed and x, I know that the smallest one is just x. And out of y squared and y to the fourth, I know y squared is the smallest one. After you identify the GCF, what you're going to actually do is divide it out of both terms from the original problem. That's what factoring is. It's breaking it down to what was multiplied together before we got here. So when I divide out the common factor, that's what we find. 9 divided by 3 is 3. X cubed divided by x is x squared. The y's cancel. I have minus 5. The x's cancel. And I'm left with y squared. So you can see that before the problem got here, it was 3xy squared times 3x squared minus 5y squared. So this whole thing, GCF included, is your factored answer. So let's work on a couple more examples like this. Here, this time we have 3 terms, but it doesn't matter. You just want to look for the common factor one by one. So again, I'm going to focus on the numbers. I can see that they all have a 5 in common. And then I'm going to look at the x's. X to the fourth, x squared, x to the fourth. X squared is the smallest one possible for them to have in common. Y squared, y5, y7, the smallest one is y squared. So this is my actual GCF, but like I said before, once you find your GCF, then you actually have to do something with it, which is what? Divide. You need to divide it out. So I'm going to show myself dividing every single term in the original problem by my GCF so you can see what is left. And we always put what is left in parentheses. So I'm going to end up with a 5x squared because the y's cancel, a positive 3, x's cancel, y cubed, and this is going to be a minus 1 x squared y to the 5th. So we have our GCF in the front and our answer after division in parentheses, and the whole thing is considered our factored answer. Let's do one more. Same thing here. We have several terms. I want to concentrate on the numbers first, 3, 9, and 21. We do have a 3 in common. We have x to the 5th, x to the 9th, and x squared. We're going to take the smallest one again. y10, y4, y12. I'm going to take the smallest one again. Then I am going to divide the original problem by my GCF and get the quotient of what's left. So 3 divided by 3. Actually, let me show myself actually doing it because I feel like it's easier to see the final answer when you actually write the division out. Those cancel. I'm left with y cubed. Oops, that's not a y. That's an x. X cubed y to the 6th power minus 3 x to the 7, those cancel, and then plus 7, those cancel, and y to the 8th power. So this whole thing would be my final answer.